Hey guys, it's Vince. Today in this video, I am excited to release an actual client's Mach3 to Pumotix migration. And this, I feel, is going to answer many questions for you all. And again, this was actually created by a past client of mine. His name is Rick Perry. Rick Perry did an extensive review on retrofitting his Chinese 6040 with one of my G540 turnkey controllers. You'll see it all in this video as far as what his setup is. You can also check out his channel. I'll put his links in the video description once it's been completed. You'll also notice my contact information beginning of the video and at the end if you guys have any questions. Without a doubt, this is the most detailed, in-depth look at just how fast it is to move from 15-year-old software to the latest, greatest 64-bit motion control software available. And when I say that, I'm going to cover in extensive detail some important points. Rick did an excellent overall job explaining everything, and he really didn't pull any punches. I mean, I'll tell you what he found interesting and what he went through. And again, very, very detailed list of what he actually went through to complete this migration. And I love it because I get a lot of questions on just how important is it to document everything, and you guys get to see it in this video. That being said, I don't want to waste anyone's time. The video's already been running for a minute and your time is as valuable as mine. I'm going to tell you right now, this is not going to be a short video. So set some time aside. If you're really serious about learning, this is going to be key to put the time in to see how this process is done. But once you see it, I think we'll all agree, especially with more videos coming, just how powerful Pumotix is in terms of just crossing over, so to speak, that gate of what's already currently available. So let's jump right in and let Rick take over.
Alright, so I want to go over a few things here. We're going to do the upgrade to Pumotix, but I wanted to go over the machine. So this is a China 6040 CNC machine that has been massively upgraded from what you would buy on eBay with the stepper motors, the spindle. There's several things that I've done to this machine. The Gantry upgrade is coming next, but I wanted to go ahead and get the software working. Anything that I cover in this video is not covered on the tan or the black box controller that comes with this machine. This machine is controlled with a Gecko G540 drive, and the box is purchased from Vince from eDealers Direct. It's this box down here. So anything I cover in this video is not guaranteed would work with a stock chassis 6040 CNC machine.
Okay guys, just to highlight what Rick is explaining, many of you that purchase the standard systems off of eBay come with a black controller, a tan controller. Vendors in China use all kinds of controllers. They use all kinds of drives, all kinds of breakout boards to formulate their controller to actually automate this chassis. He is detailing the crossover using one of my systems, which again he explained is a G540 for my novices out there who aren't familiar with this yet. All of these settings that he's discussing are for a G540 system. They will not be for representing that of the OEM stock systems that come bundled with the 6040. Now, if you have one of those boxes and still want to use a PLCM, you must, and I'll say this again clearly, you must have all of the settings represented to control the system from the vendor you purchase from. I will not have those settings. No one will, because they're the only ones that know the hardware that was used. And again, those settings are allocated by the specific hardware you're using. So let's continue the video so we just make that very clear from the get-go.
To lay that out there before I got going on this, if you're interested in upgrading your machine, contact Vince at eDealers Direct and he will set you up. Now on to the video. Hi guys, welcome back to the channel. So today I've got a new package in, and I'm going to show you what my newest upgrade to my 6040 machine is going to be and why. So the why for the upgrade on the controller is right now I have a Windows XP machine running Mach 3. Well, Windows XP machines are getting hard to find, and machines with parallel ports are getting hard to find. At Newfangled Solutions, you can buy a legacy plug-in parallel card so you can run Mach 4, but I kind of don't want to do that. I want to do something a little different here. So from here, there's a new company, Pure Logic Pumotix. So this is the kit that I got from Vince at eDealers Direct. He's the guy that you can get all this from. So basically, here's the controller. And what this is going to do is this is the controller over Ethernet. I wanted to do Ethernet because I didn't want to use the noisy USB like a UC100. And if you want to know what I mean by noisy USB, if you've ever had a hard drive you're moving large files to, and you got to move the mouse around, and sometimes it gets jerky, that's what I'm talking about with noisy USB. And you don't want that happening when you're sending G-code to your controller. You don't want to have your wireless mouse and your pendant or anything like that that's causing any kind of problems with your G-code.
So I want to stop the video there and go in a little more depth about what Rick is talking about, which, again, he's absolutely right. He's actually relating this noise issue to actually PC components. But when it comes to CNC robotics, and we're dealing with USB, everybody needs to be on the same page that USB is functioning off of 5 volts that's powered by whatever computer it's plugged into. Okay, so the port that's on your computer for USB, whatever type of port it is, if it's USB 1, 2, or 3, you're going to find that it powers the unit that's connected to it through that port. Well, of course, PCs, number one, are very seldom grounded properly. So we do find lots of ground loop issues with PCs, especially laptops. Laptops have no actual real solid ground because, again, it's portable. So you have to think about that. You have to take into account what we're working with, and you have to take into account that with a voltage fluctuation, because again, as a CPU is throttled with a computer, you're going to find that the voltage is going to fluctuate slightly, and it only takes a couple millivolts to cause a sync error, and he brought up the UC100, and that's typically the error you'll see. If you encounter a sync error in the middle of your cuts, it screws up your whole project. Many of you have asked me about this, many of you have encountered this, and this is why I chose to go with Ethernet as well as Rick, is because what he's explaining, again, is he's really covering the PC side of things. When we're dealing with CNC robotics, we want maximum stability for our step and direction signals, regardless if you're using a servo, a stepper, whatever it is. A lot of misinformation online that, you think that you're going to have more stable signals with a servo over a stepper. They all work in virtually the same format. They all rely on signals from the motion control software to allocate motion. If those signals become corrupt, your project becomes corrupt. And if that happens, it could be catastrophic. And let me paint you a picture, because I've had many clients do this. You have a $500 piece of carbon fiber on your chassis, and you're milling it. You screw that piece up, now what do? You might be able to get the system back as far as, hitting the e-stop, recycling everything. But if there's a cut that was made that you can't save on a precision substrate, you're going to be in trouble, guys. And I say this all the time, and that's where Ethernet really comes. And again, we're looking at the latest technology. When I say the latest technology, first of all, this unit runs on 12 volts. It's the only Ethernet controller that does. Even the Warp 9 ESS in the turnkey solution I offer is only 5 volts. This unit is 12 volts. The higher the voltage, the more bulletproof it is in terms of EMI penetration, number one. Number two, the stronger your signal source is. Now we're jumping from 5 volts to 12 volts is absolutely massive the difference in stability. So keep that in mind, and again, Rick is absolutely on point with this.
So Cat 5. So he includes a special little grounding block
This is not a grounding block, guys. I think he just got confused because he's seen that, like what I incorporate with the UC100 and whatnot. This is an EMI filter. He'll see it once he unwraps it. He had a lapse of judgment right there. But again, the EMI filter is included once again to give you the best overall protection. It's a ferrite gender changer essentially. Uses a magnetic field to filter out any of your signals. Is it required? Most likely not, because again, we are using 12 volts, but I say I want you to have the most bulletproof performance, and I'm not kidding. That's what we provided.
It goes on the, I forget what he calls this. Anyhow, it's for ESD, for static and grounding. And you get a new 6-foot DB25.
6-foot DB25 is used to extend the PLCM away from your system so that you do have clearance, because this module is kind of big. So if you needed more clearance, you've got the 6-foot DB25 to plug it in. It also gives you an extension away from your system. So again, trying to cover all the bases, give you guys many options to use your system.
Cable. You get a double shielded Cat7 cable to go from your computer to the controller. This is your power supply, and this is the little pigtail that plugs in to the controller. I'll lay it out and show you how it connects together here in just a second. Alright, so here's everything laid out. So you get your power supply, and this will be your power switch.
And just so everyone knows, the power supply, you can see the barrel connector here, plugs into the actual power switch so that you essentially have an inline switch to cycle the unit on and off.
And it has a little Euro block on the end of it. And this plugs in to the side here, like so. The only complaint that I have is I never like using soldered wires on Euro blocks. The correct thing would be to use wire ferrules. So this would be the only thing that I would possibly change, would be to put the wire ferrules on the wire. Because when you have a soldered wire, you have a round solder wire and a flat, the little piece in here that's flat that you screw down to it. So you have this arc and you have a flat piece pushing down on it, and you don't have very good contact there. It can actually come out because the solder doesn't give, and these screws aren't strong enough to bite into the solder. So when you use a wire ferrule, this crimps into a square, and you have a flat surface pressing onto a flat surface. That's the only thing I would change on this. So, yep.
So guys, with his one complaint there, just so everyone knows, if you guys prefer to have the ferrules actually on the leads, I will absolutely do that. As Rick stated, these screws are tiny. Okay, and actually all electronics we're looking at doing is basically making contact with that screw to the actual conductor. That's it. I get that question a lot. You know, guys think you got to really cinch down these screws. You really are not supposed to be doing that. All you're looking for is a solid contact. And again, this unit is simply powering your PLCM. So you're not supposed to be pulling on it. You're not supposed to have excess stress. Of course, I feel that this is kind of common logic type stuff. But again, it is a good point to discuss because these are precision electronics. These are not designed in a functional aspect to have stress on them. And when I say stress, they're not designed for mechanical stress. So once again, I mean, to me, to add ferrules to this, absolutely not a problem at all, whether you prefer them or don't, whichever connection you use, as long as the proper tension is used. And when I say proper tension, these screws are not to exceed 10 ounce-inches of torque. I want you to think about how small that is. It's tiny. So whether we're using a ferrule, whether we're using a solder connection, either one will work, and in that applicational use, it's really just a question of preference, as Rick said, and I certainly want to keep everybody happy. So whichever you prefer, just let me know.
This is your Emi filter. There's your controller, your Cat7. So this is basically it. It's the turnkey package. You don't have to do any.
Now, like he just explained, this is a turnkey package. So what you see here is done. There's no circuit board to wire. There's no standoffs to install. There's no drilling, no milling, no funny business. Everything here is plug and play. Once you actually plug this power switch into your power supply, plug this in, attach your Cat 7, attach your DB25N to your actual system, guys, you're ready to go. I mean, I want you to really think about that, on how fast it is compared to what's currently on the market. There's nothing like this on the market other than my ESS turnkey solution, which is why I designed that as well. I want to keep things simple. This is as simple as you can get.
Research, all you have to do is just take it out of the pack and plug it in. Alright, so this is the part where we're going to write down all the settings in Mach3. And I had already written down all of these settings for my dog tag jig. So these are the 20 different offsets to fit the fixture that I had built for this table.
Look at the amount of work that this gentleman just put in to do all this, guys. I mean, when I see this kind of work and effort put in, it really makes me appreciate the amount of work and effort I put into the system, because this is what I mean by the level of detail required to really understand what we're doing, because now he has a hard copy for whatever software he uses, regardless of Pumotix, regardless Mach 3, Mach 4, whatever you choose. All of this should be done on all systems. You can see how neat it is. He's got it in a nice little book, and he's all set. Something ever happens, you always have something to refer to.
So I'll just turn back a couple of pages here and start writing all the settings down. So we'll actually go up here, and I'll be able to go to ports and pins, and we'll actually go through all of these. Now I'm going to write down all of these, whether this is high or low, what step pin and directional pin for each axis, the input signals, the pin numbers, port number, any other deals like the output. So this is my, one of them's my spindle, one of them's my air pump. Don't have any of that, but I'm going to write down everything that I have. The spindle set up. Then when I get done there, I'm actually going to come in here, go to motor tuning, and I'm going to write down the settings that I have for each axis, so that I can migrate these settings over into Pumotix. Alright, that's pretty much it. You can see I do have a licensed version of Mach3, but I want to go ahead and prepare myself for the inevitable, which is one day this PC is going to die. So it is an old Windows XP box. I actually have a second one in the attic, but I'm not going to chance it. So I'm going to go on ahead and upgrade.
Guys, I cannot emphasize enough what he just said there is a mouthful. Many of you are using older PCs and you don't take it as serious, I feel, as you should, until a hard drive fails, the processor fails, it overheats, so many different things can happen. And again, it's the central processing unit of your entire robot. If anything happens, neurologically, you're screwed. So I'm telling you right now, it does not make sense using old PCs to support your system. I know Mach3 is older software. I hear that debate a lot. But the bottom line is you're doing a lot of math. And right now, a modern Intel i5 CPU system is really, really cheap. And even the AMD multi-core processor systems are really cheap. Invest in the best system you can afford that is up to speed with the task at hand. You're trying to automate a precision robot. Use a system that you are feeling comfortable with as far as what we're looking at as reliable. And I cannot emphasize that enough. I see it done all the time where guys are investing $20 or $30. I hear guys tell me they buy stuff at flea markets, and then they wonder why they have issues when, again, we have to look at this from the perspective of what we're doing. If you're looking at it as a hobby and you're not doing anything of value, which I find hard to believe, then I guess the choice is up to you on what you want to use. But if you plan on ever making money with the system, I'm telling you now, if you have to save a little more to invest to do it right, and I guarantee you'll appreciate it.
To the Ethernet controlled setup, and I can actually use my laptop. So here are the page for your step and direction pins for your X, Y, Z axis, A axis, and the spindle. So we'll write down these X's. The step pin is 2, direction 3, 4, 5, 6, 7, 8, 9. This may not be the same for your setup, but copy your settings from Mach3 to put into the new software. And don't forget spindle. This is pin 14. This is where the PWM signal comes from the controller to tell your spindle controller how fast to turn. This one kind of got me on the first go around of settings. I forgot to put 14 in here. But anyway, copy these settings over and I'll show you where to put them in Pumotix. Alright, so to get this glare off of there, there we go. So now we're going to do the setup, pardon me, of all the settings. So the way the Pumotix works is your computer is the server and the actual controller box is the client. And while making the video, I saw that there's some people that's worried of the word server, thinking that you have to have this thing connected to the internet before it will run. No. When you see the server address 127.0.0.1, that means this is your computer. That's what that address means. So when you see the server and that means your computer's the server, not a cloud server. Alright, so we got that out of the way. Here's our setup screen. Here's my book that's got all of my settings, and I'm not going to continue to...
Once again, guys, look at how neat this is. It's absolutely excellent. One thing I want to point out here is up here at the top, you can see he had his kernel speed at 25,000 hertz. And I want to cover that with you later on in the video. But overall, looking at the way he documented his settings, I hope all of you take a page right out of this book and do the exact same thing. Because again, very neat, very concise, and he's got this as a full documented record should, God forbid, he ever needed to, whether again, change software, re-upload it into software, whatever it may be, he's documenting everything. And again, it's part of engineering, guys. You have to start documenting everything because in a digital world, we have digital failure. So please be careful and take notes, literally, on what he's done here. It's a fantastic example.
Go to this, but you saw whenever I took all these notes from Mach3, all my inputs and outputs. So I'm going to show you, pardon me, show you where you go in here to apply these. So you start out, you got all these tabs that run down the side. So you start out with motors. Motor 0, 1, and 2. That's your X, Y, and Z. And so you can actually choose what it's supposed to be. It's already set up X, Y, Z. I've just added the A axis.
And just one other thing to clarify right here, wherever you see this little pencil, if Rick chose to, he could actually come over here. Let's say he was running 2 different type torque motors, for instance, on a specific axis. He can allocate any of these to any labeling he would like. And I think that's very helpful to mention because a lot of times guys get confused in terms of, well, what motor do I have here? And I forgot the torque here. You guys got a lot of stuff going on. This makes your allocation in terminology that you understand much easier.
And when I showed you in Mach 3, the pin association 2, 3, 4, 5, 6, 7. This is what I was looking at in Mach3. So basically I just entered these settings and went and tried the machine. The axis went the wrong way, the x-axis went the wrong way, so I just had to invert it to make it travel the correct way. So, pardon me. That's why you see one of them's not inverted, the rest are. Okay, then I go to the axes here. And so this is where I entered the information from Mach3 for my motor tuning.
Okay, guys, this is where things get really interesting. As you heard him just say, he migrated all of his settings over from Mach3. Now, what I want to point out here is two actual registered real-time examples of the hertz being used for specific axis. Why I want to point that out is for my engineers out there, you already know where I'm going with this. For guys out there trying to understand the performance level of Pumotix versus other software, I'm about to point it out right now. And this is something you'll be able to test, and I've got video footage showing the performance differences that I will be covering shortly, not only in Russian, but also in English. And again, very, very interesting. But I'm going to point something out here very interesting too, so you guys understand a major difference. You saw that Rick wrote down that he was running his past system on Mach3 at 25,000 hertz. If we look over here and we see that this axis, which is the x-axis, after he migrated his settings over from Mach3, you could see that the step frequency he's at with this specific axis in real time, and I'll say that again, in real time, is 25 hertz. The Gecko G540 supports a maximum hertz ratio of 100. He's only using a quarter of the potential speed of his system right now. I want you all to think about that, because Mach3 and other software does not reflect the actual speed each particular axis is running in real time. What does that mean to you? That means your operational envelope, you will know where you're essentially at in terms of how low or how high, meaning how close you are to the maximum percentage of the hardware frequency you have available to use for speed. The higher the frequency, it's real simple, the higher the frequency you're able to achieve, the faster your system behaves overall. But what's really interesting is, with Mach3, you set up the kernel speed, and then you have to go in and fiddle, and hopefully you'll get more and more speed out of the motors through motor tuning. What you see here, and we're going to cover later on with axis calibration, he doesn't go into full detail, but we'll cover some specifics about the calibration wizard is, he can see here, he has a lot of meat left on the bone. I mean, he's only using a quarter of the speed available on his x-axis. Now, what does that mean? That means that in order to get closer to that 100 kilohertz rating, he would have to actually take the system, recalibrate everything, and if his transmission can support the speed differential and all the variables that are involved with the mechanics, he can increase his speed, reducing his machining time while still retaining accuracy, which increases overall performance. Now, I want you to really think about that, okay? Because now you have a true-to-life number that's represented to tell you where you are in reference to what your system is actually capable of. This is super powerful information. Once again, like I said, my engineers out there know what I'm talking about. This actually gives the end user a defined value of operational envelope per their system. This is very, very interesting. And again, it's the only software that offers it. I'm going to hit play now.
And you're going to do Y. Enter all the information. Z. Now you'll see that.
Now see, he just went to Z, and you see the steps frequency has changed. So his Z-axis is performing a little better than his X in terms of available hertz rating, meaning his operational speed is faster.
This chart, whenever you actually activate, you turn the controller on, or if you make a change, it'll show you. But as you're going in here editing, you won't see it. Then you have your I/O. So So this is where you go in and set up like your e-stop.
Just so everybody understands, I/O, input-output signals. For my novice guys, input signal parameters are on the left. On the right, we've got output signal parameters. You can see I get a lot of questions still on this. What can be added? I mean, you've got a plethora of options.
In your probing pin, output signals, your mist or your flood, pin 17. And I think that's about it on here. I do not know what multiplexer is yet. I'm just in the
multiplexer, just so everyone is aware, is going to be more for advanced commercial type machining operations where we want one or two axes to work simultaneously to accomplish one job. And again, my engineering buddies in Pure Logic will chime in on that, but these features are very advanced. And again, this is what the future holds for what we're seeing, where that crossover between civilian robotics goes more into commercial robotics. And that's what we wanted to do. We wanted to have a crossover venture between software that could do virtually that with a pivot, so to speak, as far as functionality. And again, that's what the multiplexer options achieve.
Line set up. G-code, this is a specific like your XY plane. Most of all this is set up just like it was out of the box. I didn't have to change any of this. Spindle, I did have to change something on the spindle. So I had to tell it pin 17 on the mist. I had to come over here and tell it pin 14 on the PWM and pin 1 on the spindle CW signal. Those are the three settings that I had to change on this.
One other point I want to point out that Pumotix is the only software that also incorporates a spindle encoder. You've got it right here if you do decide to use that. And again, that will give you absolute accuracy as far as RPM use with your spindle. Something, again, that a lot of guys have requested, especially if we're doing real precision type work. This is the sweet spot when you're actually dialing in end mills, especially new ones.
Page. And that's about everything I've done. You know, there are other stuff you can do in here, but the things that I just talked about is all that I've done just to get control, motion control. Now, I've calibrated the travel, but we're not going to go over that in this video. I just wanted to make this video to show you how you go in here and enter your settings in from Mach3 to Pumotix, and that puts you right. Okay, I hope this helps. If there's any other questions on this part of it, just leave a comment in the video. So let's continue with the rest of the migration. Alright, so back on this screen here, let me show you, I had to get my...
Just to clarify, the screen he's looking at is the diagnostic screen. You can see all of your LEDs right here. One thing I want to make very clear about Pumotix is it also breaks down each axis individually, along with step pin and direction pin and even enable pin LEDs. So you guys can actually see diagnostically what each drive is doing for each axis, even if your LEDs are not present physically on the drives you're using. Super powerful stuff, because we know the G540 is a very simple system. You don't have step pin and direction pin LEDs on the drive. In the software now, you can actually see them firing to make sure that a drive is functioning correctly. Again, no stone was left unturned with this. You're also going to find, as he covers his limit switches, over here you'll notice that you've got a home pin, a limit middle, and a limit high. Now, of course, you're going to see his home pin and limit low become active, because again, that's his limit low, meaning that he's at the extension of his axis. You do have the option in Pumotix to also add a limit switch in the middle and a limit switch on the opposite end if you decide to, for a limit middle and a limit high registering.
Settings. So I go to the I/O, and I have limit switches on the machine for homing and for keeping me from crashing it. So I had to come in here, user 0, User input 0, pin 11, it's my Z limit. Input 1, pin 12, Y limit. And user input 2, pin 13, X limit.
I love how he did this, and again, many of you are going to love this as well, that he can write in whatever terminology, once again, he'd like to allocate to recognize what these signals are for. I cannot tell you how many guys hate trying to interpret whatever motion control software they're working with terminology for what they're actually trying to set up. This makes it all too easy because the end user knows exactly what it's for.
So I had to enter that, and then I came to this screen, and whether to know whether to change it high or low. So if you go back to our settings here, if I go down, and let's say my X, if I invert this, hit apply, you can see that we're lit up here. So when I first copied the settings over, I had a few things that was showing up here. So I wanted to go through and change to high or low until I had nothing lit up. So right now, if I click the X limit micro switch, you see it goes off. And if I do the Y, okay, so I'm going to have to go in and change this back the way I had it. So we go O, and there's where I will uncheck that, hit apply, and OK. So now if we hit X, we get in here with the stick. So there's my X, and then Y. You have to take my word for it for the Z. I can't reach it right now. So anyhow, then you can see the output signals, the E-stop state. So if I come over here and activate this, this goes away. We're in the idle state, milling mode active. So that's it. Now we can start doing a little testing on the machine, but I think I pretty much have these where I want it. If I click a micro switch, there we go. I clicked one of the micro switches and E-stop was activated. So this tells me I have the micro switches in the right place. So if I reactivate it, we're milling active. I'll go to the X limit switch. And you can watch this. This will change and the E-stop will change. So it was like it sensed too much travel. The E-stop state was on. It put it in the emergency stop mode, and that should be it. So anyway, let's do a little testing and see if we can cut some chips.
Before we do that, guys, I just want to cover real briefly the soft limit integration that Rick chose not to use. And again, that's fine. The inputs, as far as using switches, you saw exactly how easy it is. He did explain this perfectly as far as going through and showing you how the console is actually shifted into the off position, E-stop triggered when a limit is exceeded. The soft limits in Pumotix are unlike any other system, and I made sure of that when we were covering the software, that number one, they are active upon you setting them up. From the time you turn the system on and you turn it off, it memorizes that these signals were already activated. This means that your system has the best level of protection. Now, using a physical switch is still fine if that's what your preference is. If that physical switch ever fails, Rick's system, like many others, will not be protected. He may not know that, and inevitably you'll have a crash. If you use soft limits and the computer is running, which it must be in order to be actually programming the robot it's working in correlation with, you will always have massive protection because the soft limits are always active. How advanced are the soft limits in Pumotix? Well, everybody that's familiar in Mach3 with my soft limit video, if you checked it out, and even if you haven't checked it out and just messed around with soft limits, you'll realize there's what's known as a soft zone setting in Mach3. And what that soft zone setting is is it tells Mach 3 when to slow an axis down as it's approaching an end stop. Well, in Pumotix, you don't even need to enter that. It calculates its own g-force calibration to the motion being created by that axis to know when it needs to hit the brake, so to speak, to properly slow down as it's approaching the end stop. Now, I want you engineers out there to think of the math that it took to do that. That's very impressive. You don't do anything. The software calculates everything and handles that burden. So the end user simply puts in the limit of travel. They're done. The software does the rest. And once again, with the autonomous activation, once the software has been set up properly to allocate those end stop positions, from the time the end user turns the software on to the time he shuts down and returns it on again in the morning for more production, his robot is always protected. Very important to bring up.
Okay, so after plugging in all the settings, you come right down over here, and it was off, so let's turn that on. And we can use these buttons here for jogging X left and right, or right out of the box without changing anything, the same hotkeys that I used on Mach works here. So I've got the left, right arrow, up, down arrow, page down, page up. So we got left and right arrow, left, right, then the up, down, and then the Z-axis. So all these work perfect. So now we'll come down and go to the spindle right here. And then I'm going to click it. Spindle's on. Spindle's off. Then we got mist. I don't know if you heard the pump running. So pretty much that was an easy import of settings from Mach straight over to Pumotix, and we're good to go. Now I'm going to check, make sure the travels are correct, and check all the things before I just start running programs. But out of the box, that was pretty simple. I'm pretty impressed with that. So good job, guys. So anyway, so let's do a little bit of tuning and make sure we're good to go. I want to make sure that my units that I set in the motor tuning, not turning. So if I come over to motors, or axes, then I want to make sure that my steps are correct for the amount of travel that we're going a certain distance. So I'll set up a 12-inch and command it to go 12 inches and make sure that we're good there. And if we're good there, then we should be able to run some programs. Alright, so here's a section that once you get all your settings entered, this is where you need to go to calibrate, to check to make sure that your units per revolution is correct from Mach to Pumotix. I'm not going to go over that in this video because it's, setting up a gauge on the machine, blah, blah, blah. We might do a separate video of calibration. This video is basically just from getting Pumotix fired up and running your G-code. You just go to Calibration Wizard. You choose the axis that you want to check. And
I want to just briefly stop and explain some real detail of how advanced this Calibration Wizard is. And I'll let Rick continue. You can see here where you select the axis, of course, but right underneath that, what you'll notice, or I hope you can notice, because again we're panning kind of back here with the camera, the feed rate is also programmed in for calibration. Now many of you that are familiar with Mach 3 realize there is no feed rate that is programmed in for calibration, simply meaning that it's arbitrary. The software will set up a default speed, measure typically to a dial indicator or precision measuring instrument at a 1-inch rating, and that speed then has to be fine-tuned over and over again, readjust it in motor tuning until you find the sweet spot, the operational envelope, so to speak, before we miss steps or we lose accuracy and then we back off. Well, when we designed the actual calibration module, the guys actually went in and made it so that the software arbitrarily sets a default speed, but you, the end user, can manipulate this speed over and over again independently. So as you're calibrating, you're actually killing two birds, so to speak, with one stone, because you're then calibrating to this particular speed. That's very interesting, because instead of you having to do a separate motor tuning session to find out, okay, well, I've already calibrated to 200 inches a minute, if that's the measuring matrix you're using in Imperial, you'll then go up to 300 inches a minute and see if the system will still hold the same calibration, meaning the same accuracy going faster. And we keep doing that to find that operational performance, once again, envelope. Well, now you've streamlined the process because you first have to actually program in the software the speed at which it's going to perform the calibration after selecting your axis. And then once again, you will keep increasing this speed independently on that particular axis until you find that steps are missed or, again, we lose accuracy. If we're not going to have that level of consistency, and that's the key word here, and I recommend at least 5 actual measurements, minimum of 5. My precision guys do 10 to 15 per axis, and what they're looking for is that consistent level of repeatability. Once you find that, you're golden. And you look for that consistent level of repeatability in both the excess, meaning your excess travel. If you notice that your system is off in calibration, you're looking for the same thing. And then you'll pull back 5% incrementally at a time of this measurement of whatever you put in here for your speed until the axis then shows that the accuracy is well attained. Again, doing this is more of an art, guys. The guys that know how to do this, you can get a robot that is so precise, it's frightening. And especially when you incorporate, a high-end Mitutoyo precision measuring instrument, a Starrett, a Federal, whatever it may be, you are going to have an amazing robot. But I wanted to point that out because, again, unheard of feature in a calibration module of any motion control software currently available. The next feature he did not discuss is the gantry alignment mode, which for guys running a slave axis allows you to independently calibrate both of your y-axis motors. Think about that. For my guys out there running a y-axis that has slave motors, where we're running 2 motors on the y, you always hear that term racking or a motor coming out of square. Not when we're using the digital interface of the software, because again, you're actually able to program in each motor independently. You can also adjust steps per unit for each motor independently on a slave axis. Okay, so when I tell you the most advanced platform, I'm not kidding. This has got a lot of thought into it. And again, I hope Rick goes through and does do the calibration video, but he's absolutely right. It does take a lot of time to do, and especially to do it correctly. So I'll let him continue.
I don't have the machine turned on right now, but basically you choose the axis and you tell it how far that you want to move. So if we do X and we just say here, we enter in, for instance, 12 inches, and then hit run, it will tell you, it'll run the 12 inches, and then it lets you put in here how far did it actually go. And the more time you put into measuring this, the more accurate you can make it. If you just have a pointer pointing to a tape measure, you'll probably be within 20 or 30 thou. But the right way would be to actually set up a dial indicator and actually do a dial indicated move. So that's why I'm not going to go into this part, go into calibration on this video.
One other point I want to make is that, like Rick just specified, that if you do the measurement, it's going to tell you over here you would actually input the measurement taken of what was actually physically calculated by your measuring instrument. If it exceeded it, if it was under it, whatever it was, you'd input that here. And then this box underneath here will auto-calculate the step that is required to achieve that new adjustment. Okay, so all the math is taken forward with the software, leaving the end user, again, free, because there's a lot of math involved here. And again, the software does all the math. All you do is use your precision measuring instrument to, once again, measure the actual move in real time, and the rest is up to the software.
Do that in another video. But anyway, I just want to tell you, the calibration wizard is set up so that you can do your X, Y, and Z calibrations and be ready to cut some chips.
So again, I want to thank Rick. I think he did a fantastic job explaining everything. I think many of you are going to get something out of this. Again, his practices are amazing. He's been at it for quite some time. I cannot thank him enough. To all of you out there, I know videos always lead to more questions, but I think it's safe to say Rick's initial video was only about 22 minutes. This video is now in excess of 50 minutes because I'm talking and explaining a lot of stuff. But overall, it's a very straightforward process to actually go and switch over from Mach3 to Pumotix. So again, very, very interesting to see. Again, if you guys have questions, require quotes, consultations, whatever it may be, message me direct at storm2313@gmail.com. You can also message me through my eBay store. You'll see those links again at the beginning of the video, at the end. Please also leave some comments on Rick's video. He took time out of his day to do this. This was a lot of work. I really appreciate it. And again, don't be afraid to ask him any questions either. I'm sure if he doesn't have an answer, he'll message me, and we'll do our best to support you guys and get you guys on your way. Thank you all. Take care.